Hi, my name is Nick. I'm a developer advocate with ScaleOps. Look, VPA was a great idea, but let's be honest, for production, it's fundamentally broken. In our last video, we cover its 5 big architectural flaws. It's global, so it's one size fits all. It's a historian, so it's blind to what's happening right now. It's disruptive by default. It's context blind, and it creates silos that are famous for fighting with HBA. But of all those flaws, the biggest one, the one that gets SREs page, it's disruptive when it matters most. So check this out. This is our taxi API. It's a fare prediction API trained on over 70 million New York yellow taxi trips, predicting costs based on distance, duration, pickup location, and time of day. It's idle most of the day, and then, bam, it kicks off a massive nightly data ingest. This is a critical batch job. It has to finish. And this is the exact moment VPA decides to act. It sees this induced spike as an anomaly and schedules an eviction to increase the request right in the middle of the job. And the job fails. It's forced to restart. This is why teams disable VPA's auto mode. It doesn't understand your business. It just sees numbers and decides to act at the worst possible time with no context. Automation without control, that's just chaos. So how do we fix this? Well, you need a system that's actually designed for the realities of production. That's where ScaleOps comes in. Now, ScaleOps automates your entire cloud resource lifecycle, but today we're zeroing in on the foundation: intelligent rightsizing. ScaleOps installs with a single helm command, and instantly it's working in a safe, read-only mode. No configuration, no setup. You get complete visibility from the first minute. Okay, we'll get to fixing those random restarts in a minute, but first, let's look at raw workload health. I want to show you the difference between degradation and protected performance. Let's compare them side by side. On top, we've got VPA, the historian. A big spike hits the CPU limit. You can see the CPU throttle metric climbing. Your app is starving, that's performance degraded. On the bottom, ScaleOps, the first responder. The exact same spike hits, but watch that green line jump right along with it. Our burst reaction capability uses real-time data to detect the pressure and give it the headroom it needs in seconds. The throttle count, flat, 0. That's the difference between a postmortem and a non-event. But what about the restart? VPA would have killed this pod to resize it.
We are looking at Kubernetes jobs now.
ScaleOps detects it's a batch job and automatically sets its update strategy to apply the optimization upon pod creation only. Our platform captures the data to right-size the next run perfectly, but it never interrupts the one running right now. The job finishes safely. You get safety for your jobs without sacrificing optimization. Now, safety is key, but you also want efficiency. VPA treats a database and a web app exactly the same. That leaves money on the table. ScaleOps auto-detects your workloads. It knows this PostgreSQL pod is a database, and it identifies your stateless web apps automatically. This allows for continuous, aggressive automation. It tightens resources on your stateless app to slash your cloud bill while keeping your databases padded for reliability. You get max efficiency and max reliability completely hands-free. And of course, it fits your workflow. Every policy is just a Kubernetes CRD. It lives in Git, it's version control, auditable, and transparent. You set the guardrails in code, ScaleOps automates the optimization. Finally, context. Context means understanding why your workload is crashing, not just that it crashed. Because if you automate the wrong fix, you just make things worse. Step 1, classify the OOM. If it's a container OOM, you raise the pod's memory request safely. If it's a node OOM, you don't right-size the pod. You fix the node pressure. Different root cause, different action. Same symptom, totally different fix. That's the difference between automation and chaos. Step 2, make sure the optimization can actually be scheduled. If the new request doesn't fit a real allocatable headroom, it's not an optimization. It's a pending pod and a pager. So you cap it. You keep it schedulable. You avoid perfect recommendations that never land. Step 3, respect the runtime. For JVM workloads, memory isn't just a number, it's heap. So you have to align heap settings to the container budget, no guesswork. That's the bar. Correct diagnosis, safe execution, production outcomes. So this is the new standard. This isn't just a better VPA. It's a proactive, context-aware, and policy-driven system that is built for production. And honestly, this is just the foundation. Once you have this level of control, it unlocks the full power of horizontal scaling and real node consolidation. Stop writing postmortems. Start managing in real time. Get ScaleOps and get your weekends back.